Hello everyone, welcome to NPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.33. Let me make you understand the problem. In the problem, it is given that in unipositive helium ion, which is one electron species, electron transition is occurring from higher energy level n is equal to 4 to lower energy level n is equal to 2. So transition is specified here. Transition is defined here, that electron transition is occurring from n is equal to 4 to n is equal to 2. And it is also mentioned that the wavelength of quantum of radiation emitted during this transition lies in Balmer series. In the spectrum for this transition we will get one line, and that line lies in Balmer series. Question says that identify or define the transition occurring in case of hydrogen atom that will emit same wavelength of the quantum of radiation as emitted in case of helium ion. So for transition occurring in hydrogen ion, it is given that wavelength of quantum of radiation emitted will be equal to wavelength of quantum of radiation emitted during transition in case of helium ion. So wavelength of quantum of radiation emitted in both the transitions is same. And for helium, transition in helium, it is defined, higher energy level and lower energy level is defined, but for transition, higher energy level and lower energy level is not defined. Orbit number of higher energy level and lower energy level is not defined. So we have to identify the transition in hydrogen atom that will have same wavelength as transition occurring in case of helium ion. Idea is that wavelength of quantum of radiation emitted or absorbed during electron transition is equal to this, is given by this expression. Wavelength of quantum of radiation absorbed or emitted during electron transition in any one electron species is given by this expression, where lambda is wavelength, RH is Rydberg constant, Z is atomic number of one electron species, N1 is lower energy level or lower lower energy orbit, N2 is higher energy level or higher energy orbit. Now this is the actual equation that we need to use here in order to define the transition occurring in hydrogen atom that will have same wavelength as the transition occurring from n is equal to 4 to n is equal to 2 in unipositive helium ion. Now I will apply this equation first for helium ion and then for hydrogen atom. For helium ion, He raised power plus 1. Let me first apply this equation here. Now for helium ion, Z is atomic number is 2. Atomic number of helium atom is 2. So for helium ion, Z is specified equal to 2. Lower energy level, lower energy orbit N1 will have lower value of n, that is 2, and higher energy level or higher energy orbit will have higher value of n, that is 4. So I will substitute values. 1 by lambda is equal to RH into Z square, that is 2 square. 2 square will become equal to 4. 1 by n1 square, lower energy orbit, lower energy level or lower energy orbit will take lower value of n, that is 2 square. 2 square will become equal to 4 minus 1 by n2 square. Higher energy orbit will take higher value of n, that is 4. 4 square will become equal to 16. Now I can take here, I can take 1 by 4 common. It will be equal to RH multiplied by 4 into 1 by 4, because I took 1 by 4 common. It will become equal to 1 and it will become equal to 1 by 4. Now 4 and 4 will get cancelled. I can write 1 by lambda is equal to RH into 1, I may write like this, 1 by 1 square, minus 4 I may write like this, 1 by 2 square. 1 by 2 square. This equation I will label as equation 1, and this equation I will label as equation 1, and it gives me wavelength of quantum of radiation emitted in case of helium ion, when electron transition occurs in case of helium ion. Similarly, I can write the quantum wavelength of quantum of radiation emitted in case of hydrogen atom, and will be equal to, I will apply again this equation, but for hydrogen atom Z is 1. 1 square will become equal to 1, and I have to define N1 and N2. N1 and N2 are not defined for hydrogen atom. I have to identify N1 and N2 in case of hydrogen atom. 1 by lambda, or I can say wavelength of quantum of radiation emitted during transition in hydrogen atom will be equal to RH 1 by N1 square, lower energy orbit, minus 1 by N2 square, higher energy orbit. To this equation I will label equation second. Equation first gives wavelength of radiation emitted in case of for transition in helium ion. Equation second gives wavelength of radiation emitted for transition in hydrogen atom. Now I will compare equation first for helium ion with equation second for hydrogen atom. In the question it is said that wavelength of quantum of radiation emitted in both transitions is equal. So lambda, wavelength emitted for transition in case of helium ion, is equal to wavelength emitted for transition in case of hydrogen atom. Their reciprocal will also be same. So for equation 1 and 2, LHS side is same. Therefore LHS side is same. LHS side is same. I can equate RHS side. Their RHS sides, or I can say their RHS sides will also be equal. RHS side of equation 1 is RH 1 by 1 square minus 1 by 2 square is equal to RHS side of this is equal to RH 1 by N1 square minus 1 by N2 square. Coming back here, this is equation first for helium ion, this is equation second for hydrogen atom. Equation first gives wavelength of quantum of radiation emitted for transition in helium ion. Equation second gives wavelength of quantum of radiation emitted for transition in hydrogen atom. Now in the question it is said that wavelengths of quantum of radiation for transition in case of helium ion and hydrogen atom is same. If wavelengths are same, their reciprocal in equation first and second, their reciprocals will also be equal. So for equation, if I compare equation 1 and 2, their LHS sides are equal, their RHS sides will also be equal. So RHS side of equation 2 for helium ion will be equal to RHS side of equation 2 for hydrogen atom. But this is true only when RH is same for both, 1 is same for both, squares are also same. It is true only when RHS side will be equal only when N1 is 1 and N2 is equal to 2. This way, in this way, I am able to define the transition occurring in hydrogen atom that will have same wavelength of quantum of radiation as in case of unipositive helium ion. And for this transition, now I have recognized the transition is defined for me that it occurs, electron transition is occurring between higher energy level N2 equal to 2 and lower energy level N1 equal to 1 for hydrogen atom. And for hydrogen atom, this transition will result in emission of one radiation, and that radiation will lie in which series of the spectrum? For hydrogen atom, for transition and if lower energy level is 1 and higher energy level is 2, from N1 is equal to 1, it is clear that line will lie in Lyman series, and in fact it will be line will lie in represent first line of Lyman series, first line of Lyman series. Now what is the comparison? In case of unipositive helium ion, electron transition is occurring from higher energy level 4 to lower energy level 2, from higher energy orbit 4th to lower energy orbit 2. But in case of hydrogen atom, electron transition is occurring from higher energy orbit 2 to lower energy orbit 1. So concerned orbits which are involved in transition are different for helium ion and hydrogen atom. Here wavelength emitted will give one line in spectrum, and that line for helium ion, that line lies in Balmer series, and but for hydrogen atom, wavelength of quantum of radiation emitted for during this transition lies in Lyman series. Here one line in Balmer series, this transition will give one line in Balmer series. Here this transition will give one line in Lyman series, and for hydrogen atom it is first line of Lyman series. This is the difference, that orbit numbers, lower energy orbit number and higher energy orbit number in case of helium ion and hydrogen atom are different. Corresponding lines belong to different series. Here Balmer series, here in case of hydrogen Lyman series. But what is the similarity? Similarity is that wavelength of quantum of radiation emitted during electronic transition in case of unipositive helium ion is equal to wavelength of quantum of radiation emitted during electron transition occurring in case of hydrogen atom. Wavelength is same, rest N1 and N2 are different, and part of spectrum they belong, it is also different. If I compare on basis of three parameters: first, lower and higher energy orbits; second, to which part of spectrum they belong; and third, wavelength. On basis of higher and lower energy orbits, they are both the transitions are different. On basis of to which part of spectrum they belong, they are different. One belongs to Balmer, other Lyman. But on basis of wavelength of quantum of radiation emitted, they are same. They represent same transition because wavelength emitted is same for transition occurring in case of helium ion and hydrogen atom. This way you will be able to solve similar problems of same nature. If and when asked in your exams, do prepare problems of this type. See you day after tomorrow, as tomorrow is turn of class 12 students. Allah Hafiz.